Good day to all. Today we can discuss about a problem in a differentiator circuit in the subject linear integrated circuits. So this is a problem. So you are asked to design an operational amplifier differentiator that will differentiate an input signal with F max is equal to 100 hertz. A second one is draw the output waveform for a sine wave of 1 volt peak at 100 hertz applied to the differentiator. And the third one is repeat the same part for a square wave input. So before going for solving the problem, you have to know the two conditions for a good differentiator. One is choose a FA so that FA frequency equal to the highest frequency of the input signal, assuming a practical value of C1 less than 1 microfarad, and then calculate the RF value. That is the feedback resistance. Next, second step you have to follow is choose the value of FB that is equal to 10 times FA. Now calculate the values of R1 and CF so that R1 C1 is equal to RF into CF. These are the two conditions you have to go. So the frequency should be ranging between F less than FB, that is FA should be less than FB, and FB should be less than FC, that is the unity gain bandwidth of the operational amplifier. So these are the conditions you have to know. The first is so here, see this. What is the given is FA, that is the F max, which is 100 hertz. What is the formula for FA is 1 by 2 pi R of RF into C1. So FA is known. We don't know the value of RF and C1. So we can choose the C1 should be of 0.1 microfarad. So that calculate this RF as 1 by, so what should be the value formula for RF? 1 by 2 pi FA into C1. So 1 by 2 pi, FA is 100 hertz, so 10 square, into C1 is 0.1 microfarad, that is 10 power minus 7. So the value of RF is equal to 15.9 kilowatt. What is the second condition? FB is chosen as 10 times of FA. So 10 times of FA means FA is 100 hertz. So which is equal to 10 into 100, which becomes 1 kilohertz, that is the 1000. And what is the formula for FB? It is 1 by 2 pi R1 C1. We have chosen R1 and we know the value of FB. Now we can calculate R1 as 1 by 2 pi FB into C1. Now we can substitute this for 1 by 2 pi R1 as, FB as 10 power 3 and C1 as 10 power minus 7. You'll be getting 1.59 kilo ohm. The same condition is achieved with RF CF equal to R1 C1. Now you know the value of RF, you know the value of R1. Already we have chosen R1, so we can C1. We can now find out CF. So what is CF? CF is equal to R1 C1 by RF. So substitute the value of R1 1.59 kilo ohm into C1 0.1 microfarad divided by RF is 15.9 kilo ohm. You will be getting the approximately value of CF should be 0.01 microfarad. So now we have calculated all these parameters. That's the first condition. Design an operational amplifier differentiator that will differentiate an input signal with F max which is equal to 100 hertz. And what should be the values we can have is the differentiator circuit. Now the design circuit will be having, how will be the differentiator circuit? You have an operational amplifier minus plus, and here in the input side you have an R1 value is C1. So what is the value of R1? R1 is equal to 1.59 kilo ohm. And what is C1? C1 equal to 0.1 microfarad. This is your input. And here in the feedback, you have CF and RF. What is the CF value? CF value should be 0.01 microfarad. And what is the value of RF? RF is 15.9 kilo ohm. So that is connected to over the output voltage. And here, if it is a practical circuit, you will be having RCOM. This is equal to R1 parallel RF. But if you don't have that, the practical circuit means it is nested. It should be directly grounded. This is your circuit values which will be having. Second is now given the input should be VA equal to 1 sine 2 pi into 100t. So what is your output voltage of a differentiator? It is my V0 equal to minus R of C1 dVA. VA is the input. VA is taken as a sinusoidal signal. So RF value, 15.9 kilo ohm. C1, 0.1 microfarad. D by dt of 1 volt. That is your input. 1 into sine 2 pi. So differentiation of sine is cos. And inside the sine terms, you have a time. So 2 pi into 10 power 2 will be coming over here. So simplifying this, you will be getting 0.99 cos 2 pi 10 power t. So minus cos 2 pi 10 power t. The same with the cosine. So your output will be the form of like this. So here you have a sinusoidal signal means the inverted one will be the cosine signal. That is your output waveform. Sine wave input, cosine wave output. What's the third part? Third part is for a square wave input. If you are having, what should be the value? So generally, square wave input means it is represented as some amplitude, 1 volt, sine function of signum function or sine function of sine omega t. This is your input. So for a sine input, it is nothing but a Dirac delta function. You will be getting a spikes as input. That is as impulse signals. Impulse signal, you will be getting the output. At a constant input of plus or minus 1 volt. We have taken because sine function, Dirac delta function will be plus or minus. So it will be getting a plus value and a minus value in the spikes. That is positive and negative spikes of magnitude. So what will be your output? See, you have a square wave input. Wherever it is changing, there will be a, so from this low to, from it is going to high to low means you have a positive spikes. Low to high means negative spikes. Then again here it will be. So like this, you will be getting a spike in input with some plus V saturation. I mean, that depends on the supply. So 15 volt supply means some amount value will be, that is plus or minus will be 2 volt, right? So 15 minus 2 volt approximately equal to 13 volt will be, you'll be getting in the, as a saturated output. So this is the one of the problem which is frequently asked in your university examinations. Hope it will be helpful for you. Thank you.